Good afternoon, guys. How are you?
Good evening, sir. Not so bad.
Yeah, thanks for answering. All right,
Hello, sir.
yeah, man, easy puppy. I'm having I don't know what is happening. Um, but I just cannot connect to my device. I mean, I'm actually using my phone, and my phone rings quite a lot. So it's going to disturb the class. I don't use my phone for class, so I'm using the phone now just to let you know that I just cannot connect at all. I don't know what is happening. So um, oh Lord, what do I say? What do I do? All right, so let me just start off by saying, for those of you who were waiting on the start of Calculus 2, thanks for your patience. Thanks for waiting. The long-awaited moment has arrived. There are a few students who are coming over from Calculus 1 to join us for Calculus 2. Um, and we should have a fabulous time together. Hold on a minute, please. Yeah, so we should have a fabulous time together for Calculus 2. But I know I'm going to be seeing this the next class when I would be well sorted. That there are a few students of the Calculus 2 that I am very, very, very extremely proud of. Um, I would have given access to EducaSoft for the Calculus 2 students um, some time ago. And there are two students who have completed already all their assessments. And might I report that the completion of those assessments were done at 100% across board. So as it is, they have just started. Well, we are just starting today, and already they have their 20% of their final grade for the exam. Congratulations. This is excellent work. We don't start yet, but you already have your 20%. Because you've completed your EducaSoft pieces. You are way ahead and on your way to passing the course. I wasn't so well towards the last part of the calculus one. And I don't know, this morning, I kind of felt another niggle. I'm kind of not 100, but just to let you know, so if I sound a little nasal, it is because of that little niggle that I have been facing since morning. I Let me apologize again. I don't know. This has been happening for maybe one or two times too often now. But all of you so far have access to EducaSoft, with the exception of Shamari and Simon for the calculus too. So what I'm going to ask you to do, I know, you know, you know, don't want to kind of broadcast your business, but I know some of you don't have much more to do in terms of assessment. But in the meantime, I'm going to ask all of you to just go to your EducaSoft and see if you can look at some pieces, read through one or two more tutorials, and I'm still trying to sort the issues out, and I'll be back with you. I know we end at 7, but I'm sure it will be sorted out before then. All right, so give me a few. We want to do some work. Soon come.
Okay, sir.
Mm-hmm.
Good evening.
All right, guys. Good afternoon again. I'm still unable to connect. I don't know what is the problem, but let me just get some housekeeping matters out of the way for today. So again, I'm going to congratulate you for moving over to Calculus 2. And it may seem, some of you may be a little worried that it's now half the semester and, you have lots of things to cover. To remind you that you will have class on a Monday, 5 to 7, on a Wednesday, 5 to 7, and on a Friday, 6 o'clock to 9 o'clock. So these 7 hours within the week, we'll be able to make up for the time lost in the first half of the semester. So you're doing this course under block scheduling. Successfully ran the Calculus 1 that ended on Friday. And we are successfully beginning our Calculus 2 today. Just a little bit of housekeeping matters. All of you are fully aware of EducaSoft. All of you are fully aware that the assessments are to be completed and completed in a timely manner. The students of Calculus 1 understood that the task, and they were able to complete their assignments on time. There are 2 students already from Calculus 2 that completed their assessments, and with perfect scores. Already they have their 20% awaiting them for the end of the semester.
Which 2 people, sir? Which 2 people?
You want to identify yourself, you 2 people? I know them, but I don't know. You want to identify yourself? Just say me. Just raise the hand. Matter of fact, you don't have to say it now. Just raise the hand in the chat. If you raise the hand, I can confirm. But congratulations, though. They have completed their work. They have done the stuff, and I was hoping that the others would have followed suit. Kind of put you down on a little ease for the semester. Notwithstanding, though, even though you have completed the work on Educa, I will forever ask you to go through the material again so that you can be more than familiar with those materials, so that at the end of the semester, the Calculus 2 will not be a problem. Just like the Calculus 1, there are areas that will be easy, and there are areas that are going to require just a little bit more effort and energy. So we really want to spend the time, the quality time together, so it is that we can cover those tasks at hand. I will get your course delivery chart to you by the end of today. If not by the end of today, definitely before by the start of next class. The ones who were awaiting Calculus 2 already have access to EducaSoft. Those who were successful in Calculus 1, I will give them access to EducaSoft. And we will be able to, have a fulsome class beginning, maybe a little later on today, into tomorrow and Friday. It's going to be a lot of work, and I trust that you guys are prepared to get the work done up. The prerequisite for this course is Calculus 1. Why, sir? Because we're going to be building on information learned in Calculus 1 over to Calculus 2. Like Calculus 1, stationary points was a must-have. For Calculus 2, stationary point, again, is going to be a must-have. In Calculus 1, we looked at single variable functions. For stationary points, for Calculus 2, we're going to be looking at multivariable functions for stationary points. You're going to have quite a bit of multivariable functions, assign matrix, implicit differentiation, again, and of course, our stationary points. So we'll be able to understand our partial derivatives and be able to master those areas. You're going to be required to do things called like iteration. You're going to be doing things with, Maclaurin's expansion, Taylor's expansion, among other areas, sketching of graphs, Lagrange multipliers. So we're going to be looking mainly on the applications now of our differentiation and our integration. More applications, I should say. So in a nutshell, the calculus 2, yes, requires a little bit more effort and energy when compared to calculus 1. So you can't allow a day to pass without you keeping up. You have to be able to do a little bit of work every single day, or else the course is going to run away from you. When I say run away from you, literally run away from you. And we don't have the opportunity. We don't have the time to catch up if it runs away. So the moment the course runs away from you, that is it. It may sound that way, but it's also the truth. If the course runs away from you, so if you miss a class and the class is recorded and when sir uploads the recordings, you still don't go through it. That is it. That is the end of it. Start putting on your money for calculus 2, because if you miss a day, you will have that missing link that you're going to be unable to connect the dots for the other areas. It's a connective course. One thing connects to another, to another, to another. And if you miss that point, you're going to have a missing link. I recognize a trend, and I've spoken to 1 or 2 students privately about it, that you'll come to the first sets of classes and then you miss your classes. I mean, I speak to you privately, says, but sir, I'm watching the recordings. And when it's time for the assessment, either the mid-semester or the final exam, I'm seeing the shortfall because you're not attending classes. Class attendance is a must. The regulation says if you do not attend a minimum of 80% of your classes, you can be barred from the exam. Some of you are just not coming out to class. That's not good. Whenever you miss class, you are missing some instruction. Whenever you're missing class, you're missing some levels of instruction. And when you miss your instruction, it means that some concepts are going to be missed. So I encourage you. I understand also that we are all adults. You have children, you have a spouse, you have a job. But for crying out loud, if you were to miss a class, make sure that when you reach home 12 o'clock midnight or 1 o'clock, you try sit up and spend about a half an hour and just go through some work on Edico. The pre-recordings. All of you here, I'm not seeing any new students in the chat, all of you here have access to my YouTube channel. The recordings are posted. Matter of fact, I also have recordings. Most of my recordings in the channel are calculus 1, calculus 2. Most of the recordings are calculus 1, calculus 2. You have many years of calculus 1, calculus 2 from which to scroll. Find something and look through the video. I may explain something better 1 year than I do the other year. Find something, go through the recordings, ensure that you are doing your work. Students, if you don't put in the work, you're not going to get out the results. And I'm seeing it way too often. And those of you who have this fear of exams, which is quite a number of you, have this fear of exams, you need to stop it. You can't be performing well in class. And when it's time to write an exam, you're going there and go to foolishness. You have to stop it. So the fear of exams must stop, must come to an end. You cannot continue in that vein. You are just in year 3, some of you year 4. You're trying to cover up, complete your bachelor's. Some of you will have another year, but this is just the beginning. Having a bachelor's is just the beginning. So I'm going to say to you, get over that fear, get on Erico, complete your assigned task, go on the YouTube channel, complete your assigned task, come to class, complete your assigned task, and also, which is very important, what it is that you are doing on your own. All right? I'm going to pause here and ask, are there any questions of me? Are there any expectations of me? Speak now, so it is that I can answer them, so we can move into the other matters ahead. Oh, sorry. Most important point.
Yeah, I sent you a message, direct message.
Okay, I soon take it out of the another point. Is when they come to class, I'm not going to be begging anybody to unmute and answer me. Let me tell you what I'm not going to be doing for this second half of the school term. If I so choose, I can lie in my bed or sit in my couch, and I can recite iteration, and I can recite multivariable function. I can do what it is that I need to do because I already know it. I already know it. So when I come to class and I'm asking you to work alongside with me and I ask a question, I'm expecting you guys to answer. It's a basic request for you to answer. Just a simple basic request for you to answer. Unmute, answer. And I'm going to tell you why. If you don't want to talk to me, that's a problem. It's not a problem. It's neither here nor there. But a lot of you have misconceptions in your headspace, believing that you understand the topic, and it's foolishness you have in your mind. Foolishness. So when you speak to me and verbalize what it is that you have in your headspace, what is going to happen is I'll be able to decipher whether or not what it is that you're saying makes sense. And that's the only reason I asked you to speak to me now, because as I said before, I can lay down and sing those songs because I know the information. I've been doing it over and over and over and over again. So me asking you to speak is just to hear what you have in your headspace, to see if the concepts that you have are correct, so that I can undo the misconceptions. That's all I want. So please, I am not, the semester is short in and of itself. We meet 3 times for the week to complete quite a bit of information. You have to speak up. Let me know what you have in your headspace. There's a direct correlation with students speaking up in class and passing their exams. I have proven it. I have proven it. You come to class and you sit down and you try to suck up the information and you don't talk. It's not going to happen. You're going to fail. It's a waste of time. Unmute and ask questions and say to me, sir, can you explain that again? It's my responsibility. Don't think that you're annoying me. It's my responsibility to go through. All right? So now that I've spoken about one of the most important things, let me pause and ask if there are any questions that you have of me. Any questions?
No, sir.
Not at the moment,
Okay.
sir.
Thank you, sir. Thank you, afternoon. There are 10 of you.
No questions, sir. No
All
questions,
right.
sir.
All right. How many of you, by a raise of hands, how many of you work at this time after 5 o'clock? Am I to understand that? Or is it that people are working at this time? Can you just raise your hand for me, please? What is that reason for? You work after 5 o'clock?
Not really, but sometimes it happens. Not on a frequent.
Okay. Anybody else? Chevy, what does that mean?
Means sometimes, sir.
Sometimes. Okay. Okay, Adrian, I know your situation already. All right. Very important because when you again don't turn up because of work, lots of things happen. When I say lots of things, I mean lots of things. So I really want people to be able to focus on the task ahead. All right, let me try something here again now. Before clicking, just allow me to restart this device because I don't understand why it is that I'm still unable to connect. Give me a minute, please. I'm in a mute. Um, All right. I'm going to be doing, I can should just download it. Yeah, that would be the best thing. I'm going to introduce you to a concept. I'm going to introduce you to a concept. Now, this question, so the calculus 2, most of the areas that we have done, that we'll be doing rather, are areas that are going to be coming back on the exam paper. And this concept that I just looked through some stuff, and I decided to start here. Try to create some method to my madness. I'm going to ask that you all put up one hand. And in putting up that one hand, I want the palm of your hand to be facing you. I want you to be looking at the palm of your hand. Are we all there?
Yes, sir.
All right. Then what I want you to do for me is your thumb and index finger. You know, some of you man have big hand, and the gap between the thumb and the index finger could be very large. Somehow, just bring up your thumb a little closer to the index finger so that the space in between the index and the middle and the ring and the pinky will almost be equal. Can you?
Closing our fingers together, that's what it is.
No, I need some gaps between your fingers. So let me go again.
Okay, got you now.
All right, go and go still. I want you to face the palm of your hand. The palm of your hand is supposed to be facing you. You're looking at the palm of your hand. You're looking to see if you have that M in your hand that says money. Not go so here. Because toward the hand them have M and I don't have money, but never mind. What I want you to do is the distance between the thumb and the index finger is going to be wide. So raise your index finger, carry your thumb in closer to your index so that the space between your thumb and your index is equal almost to all the other spaces. Can you picture that?
Yes, sir.
Yes,
All
sir.
right, good. How many spaces are you seeing on that one hand?
4 spaces, sir.
4 spaces. Very good. Excellent answer. How many fingers are you seeing?
5, sir.
5
4
fingers.
and 1, 2.
Go about to business. A 5 finger.
You don't want to visit them.
Yes, man. A 5 finger. Now come to about no 4 finger. No one thumb. 5 finger. All right. So come work with me. So we have 5 fingers up. How many spaces again?
4 spaces, sir.
4 spaces. And how many fingers?
5 fingers.
5 fingers. Now, listen to what I'm saying. You know the reason I'm asking? And somebody may say, "No, how much time I can answer you?" Because what I just said to you is going to be very, very, very important. Don't put on your hand, you know. Boy, your hand stay right up there. And if you're all like utterly, she always trouble me, so me can't trouble her. I have permission. And don't call her out. If you're all like utterly, catch up your hand. Utterly, catch up your hand with me.
May I try?
So if you catch up your hand,
you're going to see that you have 5 fingers and 4 thumbs. 5 fingers. 4 thumbs, 4 fingers, 5 fingers and 4 spaces in between those fingers. You see the spaces in between those fingers are called my trapezoids. Those spaces are going to be called my trapezoids. You see the fingers? They are going to be called my ordinands. The fingers are going to be called my ordinands. The spaces are my trapezoids. How many more trapezoids do I have than ordinands? Listen to my question. How many more trapezoids do I have than ordinands?
Minus
one.
one.
1 less. Very good. -1 or 1 less. How many ordinands do I have compared to trapezoids?
+1, sir.
+1 or 1 more. Very good. So anytime you go into the exam and the question says ordinands versus trapezoids, you know the difference between ordinands and trapezoids. You'll know the difference between ordinands and trapezoids. Very important to know. Very, very important. If you don't catch this now, when we're going to be looking at our questions, we're going to be having serious problems. All right, you can put on your hand now. Yes, Otterly, you can put on your hand now, mommy. All right. So I'm now sharing a document with you. I'm now sharing a document with you. I never normally start teaching the topic from here, but I just want to introduce it from here. I may revert to something else come Wednesday, but I wanted something fun to start off with. Wanted something fun to start off with. So it says trapezoidal rule. This technique is much more accurate and a much more of an accurate way to approximate the area beneath the curve. Now, we would have completed calculus 1. And we would know how to calculate the area beneath a curve. It's going to be a definite integral where you have an upper limit and a lower limit. And you are going to be doing your estimation there, your calculation. This method is much more accurate to estimate the area beneath the curve. It says to construct the trapezoids. You're going to mark the height of the function at the beginning and the end of the interval, and then connect the 2 points. So I don't know what that means. Don't worry about it. This method is going to require you memorizing some formulation. And that's where I want to take us. So if we are going to allow it to be a continuous variable over the interval a, comma b, then the trapezoidal rule for approximating is going to be b the upper limit. See the interval there? B the upper limit, a the lower limit, and integrating the function f of x. See here? b, a, f of x dx. You see what is in red? It's the ugly formulation. It's the ugly formulation. Work with me again. I'm going to ask that you put up your hand. No, don't put it up yet. Let me explain this piece here first. So I have a graph on screen. Three of them are shaded. Three of them are shaded. And all three of those graphs, shaded portions, are trapezoids. They're all trapezoids. Can you see my y equals f of x? Let me spotlight. Can you see my y equals f of x, the function?
There's that B, right, beneath the
Yes,
the
I
last
do.
right there, so yeah, okay, B
Must
that.
be.
Yes.
Mm,
Yes, sir, I can see.
and up here side A. So this is like one of the curves that you'd have plotted for the single variable function in calculus 1. Where you have a maximum point up here, so. You have a point of inflection somewhere in the middle right there, so. Followed by a minimum point right there, so. All right, watch me. I have a trapezoid here. Hold on a minute, please. Hold on 1 minute. 1 second, 1 second, 1 second. Sorry about that. So each of these rectangular looking thing that you're looking at, and I want you to pay attention. When I want nobody gaze, I am trying to develop the topic. You see, if I follow the development of this topic, then can't fool you. Work with me now. These rectangular looking stuff are equidistant from each other. Anybody know what I mean by that? Equidistant.
Is that equal?
Equal
Plus
distance.
spaces.
Equal distance. Yeah. Equal distance. So equidistant comes from the word equal and distance, and they coin it and call it equidistant. Equal distance. Sir, there have to be equal distance? Yeah, yes, I. Do you remember now? Do you remember? Me asking you just now to pull up your big finger, your thumb. Yeah, talk about have a four finger. People when in their country, people don't call it thumb, they don't call it big finger. True or false, guys? Talk to me nice.
True, sir.
True,
Yeah,
sir.
man. Yeah, man. They think nobody who have time to call it thumb. At Jamaicans, Americans know we call it thumb. In Jamaica, big finger name. Big finger, soft finger. You want them a finger. Anybody remember me saying to you that hold up your big finger so that it look the space between the big finger and your index finger almost look uniform right across? It is
Yes,
this
sir.
very
Yes.
You see how them big how them finger are big? I send them finger them. Big just like that. All right? I send you please do not
Please
come
stop
in.
spreading
No,
rumor about
please do
me.
Please do not comment. All right. So these are like your fingers. These are like your fingers. They're equidistant from each other. All right, watch me. Now, each of these intervals are drawn under this curve. And where the line meets the curve here, and where the line here meets the curve here, and where the line meets the curve here, and where the line meets the curve here, these two lines are connected by a straight line here. Can you see that straight line?
Yes, sir.
Yes, sir.
Yes, sir.
there's another straight line that connects this point to this point. You may have to look very closely in order to see, but trust me, it is there. Can anybody glimpse it?
Yeah.
Yeah, this
Yes,
one.
sir.
But this one is more visible, don't it?
Mm-hmm.
So what is happening? These are called my trapezoids, my trapeziums. In this one, it is underestimated. Talk truth.
Yeah.
Because I have a gap inside here, so right up here, so don't it?
Yeah.
But what I can say about this one is, if this is under, it means this one is
That's over because there is no space, but it goes.
very good. There's no, right. So this is overestimated. Why is it overestimated? Because you see the curve come under your saw, but the straight line above it, talk truth.
Yes, sir.
Yes, sir.
All right. So this last one is overestimated. So is the middle one. The middle one is overestimated also, you know, but it's not overestimated as much as
Just
this
a
last
little
one.
pinch.
Yeah, just a little toops. Yeah, man. Just a little toops of it. All right. But the first one is a gross overestimation. But don't worry. You see this gross overestimation versus this little bit of estimation versus a little piece here, so it will take care of this piece inside here, so. It will take care of that little piece inside here, so. All right? So you don't have to
Repeat
worry.
that, sir, please.
Now I'm just saying to you, don't worry about this overestimation right here, this underestimation right here, so. Because the overestimation right here, so, the big overestimation here, so, and the little overestimation right here, so, this little overestimation here, so, plus this other overestimation here, so, will compensate for this underestimation right here, so. Put it this way. Put it this way. I'm trying to make this mathematics as real as I can possibly get it. Put it this way. I don't know if you would read, but I read enough time. Because me shame easy. I mean, I want to go at the cashier and the cashier say, oh, your bill is $68,000. I mean, no, it's at 20,000. I can't go to the supermarket. So me not go to the supermarket, go pick up nothing and then after that, now when me reach up there, so me shame. And I forgot to tell people for cashier for put back. After least me at the line, she laugh me to scorn. And say, look, one big t-shirt can buy food for people on the table. Watch me now. This is what I do when I go to the supermarket. Don't know if anybody do it. One bread costs $550. I call it $600. I have my own running total in my head, $600. One tin of milk for $325. I call it $400. So the bread and the milk is at $1,000. 1 pound of rice for $150. I call it $200. That's a $1,200. So what I continue to do is to overestimate my bill. And when I overestimate the bill, I'm going to say, all right, at 20,000, I'm carrying now. And when I reach a certain amount, I say, all right, I was overestimating. I reached $18,000. $18,000. And I calculate my 15% of that. And I reach X amount of money. And I say, yes, it still don't reach $20,000. Cashier can't ramp with me and tell me, oh, sir, your bill is $35,000. I got to tell her, when the price on the shelf wrong, and anything when the price on the shelf wrong, I mean, calculate that out of my head as that price at that price, and I get it at. You can't ramp with the eye. So I'm using my overestimation to compensate for an area that I may underestimate. Has anybody ever done that shopping before? Yeah, no?
All the time.
Yes, sir.
It's an excellent strategy. So that is where the trapezoidal rule can come in play. That is where the trapezoidal rule come in play. Watch me. The trapezoidal rule overestimates a curve, that is concave up and underestimate the function that is concave down. All right? Now work with me. Let me go back up to here, so. Put up back your hand. The first trapezoid that is formed, remember, you know, the space in between your fingers is called the trapezoid, and your fingers are called the
Ordinals.
Ordinals.
ordinals. Oh, love it. I love the class already. Excellent. Excellent. Work with me. Let us look at your first ordinal. Let us look at your first ordinal, your big finger. How many trapezoid is the big finger touching against?
1.
1.
Excellent. Everybody see that? If you don't see it, say, ah. All right, very good. So let me say it again. When you look at your big finger, the first ordinal, you have 1 trapezoid. Let us look at your index finger. How many trapezoids your index finger sharing?
2, sir.
2, sir.
Middle finger,
2, sir.
2 as well.
ring finger,
2, sir.
2.
pinky winky.
1,
1.
sir.
All right, watch me. You see the one in the blue? And the one in the blue? The one right there, so? Are your big finger. You see the one on there, so? Are your pinky winky. The one on your index finger, it has share 2 trapezoids, so that's why I have a 2. It is being multiplied by 2 right there, so. The next one will be as many of them as you have between your big finger and your pinky winky is going to be multiplied by 2. The only ones that are not going to be multiplied by 2 are the ones your big finger and your pinky winky. The start of the trapezoidal count and at the end of the trapezoidal count, you have only times 1. Times 1. Every other one of them inside. See here? The second one, this is your index finger, your middle finger, your ring finger. But the point is, I can have as many terms in there. That's why I have this plus, dot, 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 plus. I can have as many terms as I want inside here. All of those terms are going to be bounded by 2 trapezoids. Can you all see that?
Yes, sir.
Yes, sir.
Yes, sir.
With the exception of the first one and the last one. That's why those are not multiplied by
Sure.
2. Go ahead.
We can say the start and the ending of the trapezoidal rule or the trapezoidal bracket or whatever this is called.
Same so. My reason for demonstrating with your hand is that you can see it. Now hear me out. Me not playing a game for no calculus too, you know. As best as possible, I'm gonna come to class to develop my concepts. You're gonna get the development of the concepts. Any question the man them lick with it, you lick them back with it. Lick for lick. It's not hard. And the truth of the matter is, how I'm teaching this topic, I wished when I was going to school, my teachers taught me this way. I would have appreciated the topic much more and better. And I would have grasped the topic quicker too. Because when you tell me, say, the first one and the last one now multiply by 2, or only the big one, then you have to ask why. How that makes sense. I mean, I question everything. But when me say to you now, yo, how much trapezoid the big finger is touching, you can't tell me one. I may say, oi, how much trapezoid the index finger touch? You say, but wait, and I told that to the left and right? Yeah. Every one of them in betwixt will be touching 2. Only the one will start it and the one will end it. Trapezoidal rule is finished. Trapezoidal rule is finished. I won't even do an example with you just yet. Let me ask you a question. Before I ask a question, this is my formulation. You asked me to integrate something. I would have integrated this. I'm supposed to be integrating the upper limit, lower limit, f of x, d of x. I'm going to have delta x over 2. Delta x over 2 times. I just explained all of this something in the middle of the bracket. But delta x is going to be used to find the width of the trapezoid. Remember, they said to you, say, this and this equal, and this equal, and this equal, that they're equidistant from each other. We have to calculate it, the equidistant concept or value. So this delta x is telling me that I need to calculate the width of the trapezoid. The width of the trapezoid is very important. That's why I went as far as explaining the difference between trapezoids and ordinals. You will have always one more ordinals than you have trapezoids. Always. You'll have one less trapezoid than you do ordinals. When you look at a big finger, them, those are ordinals. When you look on a V, them, in betwixt the finger, them, those are trapezoids. Always. So, n is a number of trapezoids, where n is going to be the number of trapezoids. Of course, you know, my A is my upper limit, my lower limit, and B is my upper limit. So delta x is going to be B minus A over n. And that value is going to be divided by 2. So the trapezoidal rule overestimates a curve that is concave up and underestimate the function that is concave down. Always remember that. And if you understand that, I would then give you an example to do, but that example won't be done until we meet again on Wednesday, God willing. Let me apologize again for the mix up. I really don't know what happened. If ever you hear me say to you that I'm having device challenges, just always remind me to restart the computer. Because the moment I had the thought a while ago and I restarted, everything came up. And I was saying to myself, I mean, my writing tablet was out, ready for class, trying to connect, I just would not connect to save my life. And this was way before 5 o'clock. It just would not connect. So next time you hear me say I have device, just remind me now, please. Remind me, sir, reboot. That should take care of the situation. This is the second time now it's happening to me. It happened to me once in a statistics class one Tuesday afternoon into evening. And I was most annoyed. And I decided that now I'm going to reboot and it came back up, but I just never remember this afternoon. All right, do me a favor, guys. You're going to be required to work long and hard. Please, you all have access to my YouTube channel. Scroll through. Try and find something that says trapezoidal rule and try and understand it. It's not difficult. Question comes anywhere between as many as 10 marks. You can get a question like this for as many as 10 marks. Work with me, please. We have an agreement?
Definitely, sir.
All right.
Yes, sir.
Yes, sir.
Speak up on yourself. I'm going to end here. Thanks for coming out and we will talk. All right?
All right, sir.
Okay.
Thanks again.
Cool, no problem.